I will be presenting a research-based TED Talk about creating novel cancer vaccines for breast cancer using iPSC-derived antigens. Over 18.1 million people worldwide have cancer, which is roughly 6% of the world's population. These numbers are continuously on the rise, proposing cancer to be a huge problem weighing down on people. It is more important than ever to continue to research ways to prevent this disease from occurring in more and more people. Some techniques to prevent this disease from occurring is CRISPR, artificial intelligence, telehealth, infection assays, cryoelectric microscopy, and robotic surgery. However, there is a proposal for a vaccine that can be created using antigen-sharing cells that cross over cancer. Such cells are induced pluripotent stem cells, a probable way to decrease the proliferation of cancer. There has been evidence of cross-immune responses between the two. This provides hope that the body could create antibodies from the exposure to induced pluripotent stem cells that could be used against cancer. Cancer shares similar oncofetal proteins and antigens such as alpha-beta protein, CEA, and HCC with embryonic stem cells, which also have high proliferation rates like cancer. Research on embryonic stem cells arose as it could hold the secret to defeating cancer through vaccination or other methods due to overlap in tumor-associated proteins or antigens present in the embryonic development process. However, ethical questions such as tumorigenicity and alloimmunity concern scientists, so the antigens from pluripotent cells were compared with cancer. By RNA sequencing various human-derived induced pluripotent cells, it was found that there was a greater antigen overlap between cancer cells and pluripotent stem cells than embryonic stem cells. This circumvented ethical concerns, and these pluripotent stem cells could be reverse engineered from human tissues, resulting in easier access compared to embryonic stem cells. In a 2019 study, induced pluripotent stem cell-based cancer vaccines, they experimented on whole cell cancer vaccines with iPSCs. They found out that autologous iPSCs were more effective than xenogenic iPSCs. Autologous iPSCs have more tumor-associated antigens. On the other hand, when researching embryonic materials, they have been known to elicit tumorigenicity. A possible solution was to harness irradiated autologous iPSCs to create a vaccine. The reason why autologous cells were the source was to minimize alloimmunity that could potentially be stimulated by major histocompatibility complex molecules. The radiation of iPSCs was conducted to slow down the proliferation rates and prevent teratoma formation using gamma irradiation. The experiment ended with iPSCs being an effective vaccine against multiple cancer types, and that the T cells from the vaccine-treated tumors could be used as a vaccine in naive mice. T cells can hold the ability to confer immunity and protect mice that didn't receive the initial vaccine against tumors. The iPSC vaccine was able to make the immune system recognize oncofetal proteins, which are usually tolerated by the body. Surprisingly, it didn't cause a strong immune response against the own body's own cells. This might be because there are more oncofetal antigens in tumors compared to normal cells in our organs. So the goal and hope of this whole experiment I worked on was to see if iPSCs aimed against the ERBB2 positive and HER2 negative. On the other hand, developing a cancer model to then be exposed to iPSCs to induce a higher immune response, stressing the area to decrease tumor growth, is a further possibility. In this experiment, the concept of using induced pluripotent stem cells as a possible vaccine against cancer is being tested. Many studies have shown that positive results on this topic. However, while it is very important to understand the reason behind using induced pluripotent stem cells, it is also crucial to understand the tumor model itself. First, being able to consistently produce a tumor is key to ensuring that the model stays somehow similar before mice. Experimenting on cancer-associated cells is very important in this experiment. So I co-plated BT474, which is a human cancer breast line cell line, and human fibroblasts together, measuring and comparing the growth curves with human fibroblasts and BT474 in various conditions. Figuring out the sweet spot, I wanted to produce caps to identify whether these cells could replicate a more tumor-like model inside my murine-like model. In the end, I found out that by using 50% of human fibroblast media and 50% of BT474 media in the human fibroblast conditions, I was able to get the highest proliferation rates. And to ensure the accuracy of my results, I repeated it 3 times in a row, A, B, and C. Afterwards, to determine whether co-injection or co-plating was better, 2 mice were injected with cells, and co-plating provided solid results. To prove the progression of a tumor, I injected negative control mouse, measuring the rate at which matrigel would be fully absorbed. In the future, I plan to use irradiate pluripotent cells to treat the mice, testing their effectiveness against cancer. In undertaking this whole research, my primary motive stemmed from the profound impact that cancer has had on million lives of the world, including those of my friends and family members. From a personal viewpoint, I too have had family in my life die from the harsh effects of cancer. Witnessing the suffering caused by this relentless disease has fueled my determination to find innovative solutions. By exploring the potential of induced pluripotent stem cells as novel cancer vaccines, I hope to contribute to a future where cancer can be effectively prevented and treated with minimal side effects. This research is particularly exciting because it can address some of the major ethical and practical challenges associated with other forms of stem cell research. iPSCs offer a promising alternative to embryonic stem cells, circumventing ethical concerns and providing a more accessible source of cells for experimentation. By demonstrating that iPSCs can elicit a robust immune response against cancer cells without triggering harmful reactions against normal cells, this study paves the way for more targeted and more personal cancer therapies. Moreover, the success of this approach could lead to significant advancements in cancer immunotherapy, offering new hope for patients with difficult-to-treat cancers. iPSC-based vaccines have the potential to be customized to the individual, enhancing the effectiveness of the treatment while reducing the adverse effects. This personalized approach aligns with the broader trend in medicine toward tailored treatments based on the unique characteristics of each patient's disease. But beyond the technical and the scientific advancements, this research holds immense potential for improving cancer patients and patient outcomes. The development of effective iPSC-based cancer vaccines could revolutionize the way we approach cancer treatment, shifting the focus from reactive to proactive measures. The proactive approach could significantly reduce the incidence and severity of cancer, alleviating the burden of healthcare symptoms and improving the quality for countless of individuals. Ultimately, this research represents a significant step forward in our quest to improve cancer outcomes and enhance the quality of lives for millions of people around the world. By pushing the boundaries of current science cancer research, we move closer to a future where cancer is no longer a formidable threat but a manageable condition, allowing people to live longer, healthier, and more fulfilling lives. While scientific advancements are crucial in fighting cancer, the support and involvement of the broader community are equally important. There are numerous ways in which average people can volunteer and support organizations that help patients affected by cancer, making significant impact in the lives of those battling this disease. Volunteering times and skills are one of the most direct ways to help. Many cancer organizations rely on volunteers to assist with various tasks, such as providing companionship to patients undergoing treatment, helping with administrative duties, participating in fundraising events, or offering professional skills like counseling or legal advice. Organizations like the American Cancer Society, Cancer Research in UK, and local cancer support groups often have volunteer programs that welcome individuals from all walks of life. Participating in fundraising events is another impactful way to contribute to cancer research. Charity walks, runs, bikes, drives, or sponsored events that raise essential funds for cancer research and patient support services. These events also increase public awareness about cancer and the importance of early detection and prevention. Additionally, donating to cancer research organizations and patient support groups can provide vital financial resources needed for continued research, treatment, and advances in direct patient care. Even small donations can collectively make a substantial difference. Lastly, spreading awareness about cancer prevention, early detection, and importance of support networks can amplify the impact of these efforts. By engaging in these activities, average people can play a pivotal role in supporting cancer patients and advancing this fight against the devastating disease. Thank you for your time today.